Today we did a lot of talking and a lot of point of views and conversations were shared. But as Nick mentioned earlier, it's very important for us to take what we're learning from here and put this into action and execute against the conversations and feedback that was given. So that's what we're doing today. We're going to give you guys a real life scenario of a road widening project that GDOT and WSB will be working on and executing on Marietta Street right outside. So this will be showcasing how 4M and Trimble connect the office to the field using the same utility data so they can reduce risk early, coordinate better, and verify in real time. And most of all, what we heard mostly today was communicate. How can you better communicate from the office to the field in real time? So to kick us off, we'll let these guys take it away. Nick from GDOT, as you guys all know. Kausu from 4M. I'm in everyone's way here. Darren from Trimble, and Ed from WSB. All right, guys, kick it off.
George is winning, so that typically means growth. Sounds like you're looking at a road widening project, right?
Yep, sure am. So the city of Atlanta approached GDOT about a lot of different initiatives that are going on around the city. We have the Stitch that'll eventually be built across the downtown connector, and they're looking for ways to beautify the city. And so the discussion pivoted to Marietta. They want to widen to add a bit more parking. Now, to some of the old vets in the audience, that widening may sound like a glorified streetscape project. That's fine, okay? And Bill is looking at me very hard like, not another one of these. But anyhow, the city wants to do a bit of widening. Of course, as you can imagine, there are a lot of setback issues with doing any type of widening in downtown Atlanta.
Makes sense. So probably need to do a little site investigation, right, just to get started, see what we're dealing with?
Absolutely.
All right.
Okay, so the theme today has been communication, coordination, and one of the panelists said, you can't communicate what you don't know, right? That's where 4M comes in. In this scenario, you want to know what's out there. It's not about accuracy at this point of this time or in this phase of the project, but it's about knowing which are the utility owners present, where are the probable lines, and what is the scope that we are looking in terms of, let's say, SUE investigation. What is the scope that we are looking for relocation? What are the risks that you are carrying for that project? How can you know about all of that information, not after waiting for weeks and months and trying to collect all that information manually, but can we automate all of that with technology? Can we automate that with AI? That's the exact problem statement we as a company, we as 4M, has taken as our mission. How can we get that comprehensive information? It's, again, not about accuracy. It's, again, not about replacing SUE. It's about assisting SUE better. It's about making sure you guys know which are the spots in the project where you will need more boreholes, which are the spots or which are the parcels, which are the easements that you should be considering on coordination, communication. Going back to, again, that statement, you cannot coordinate or communicate on the data that you don't know. So I'm going to show you our product. We are going to do live demo. Everything that you will be seeing from this point onwards is live. So give us some grace if the internet doesn't work or whatever it is, but we are brave soldiers out here and out there, and you will see some fun stuff. All right, so this is how 4M looks like. These are some dispersed projects. If you look at an actual DOT account, it will be much, much more crowded. But this is the account we are using for tech integration, right? Each of these yellow spots that you see are projects that I have access to. So before I get into project creation, I want to talk about 4M as a technology. So what we have done is we have built something called AI conflation engine. That AI conflation engine ingests tens of millions of records from public domain. So those records are PDFs, GIS, permits, and what we do is synthesize all of those records. So for an example, in an urban environment, if you synthesize, or if you look at different GIS, one GIS will tell you the water line is on the right side of the road, other will tell you it's on the left side of the road. Which one is right? That's where our AI configuration engine takes those records, it infuses with the imagery, and builds a realistic map, which is, again, repeating myself, not accurate, but comprehensive, for you to know what's out there. Okay, so we'll start by creating a new project. I heard about a long project in an earlier panel conversation, so I'm going to do a really long road project here. And it's not an urban environment. We'll go to an urban environment, but this is more like a suburban, long linear project over here. Yeah, so that's the project. Let's call it demo. Let's use this as a design phase for a road project. And then look at view utilities. So within matter of seconds, we have our utility information start streaming in. And we further enhance this data by applying some advanced algorithms to this. So if I switch to another window, this is how it will look literally within matter of 1 hour or so. If I can zoom in, you can start to see we are streaming utility lines. So different types of lines. For an example, I can click over here. I can see that's wastewater line. Not only lines, but we also have on-surface objects. So we have this particular pole that's been captured, geolocated. One thing just to identify on-surface object, but then there's another thing to actually position that on a map, right? Here are a couple of cool things I want to show you. If I zoom out and go to this area, not only we are identifying on-surface objects, but we are also capturing road marks. So here, if I can go, this is a spray paint, one of the locates that you could see as an evidence on the map. And not only you can see that in the imagery, but you can also see it where it is located on the map. And here's a gas line that we collected from our configuration engine. So for this line, myself as an engineer, I have a very strong confidence the line is present because I have evidence showing the line is present, right? We are giving you this level of information in matter of 1 hour versus waiting for weeks and months. Let me go to utility insights on this one. So here's like our risk analysis agent on this large project that I've drawn over there. I just wanted to understand what are the risks. And our agent identified there's a parcel hospital in that area, right? If I were just cruising around, I might not know. So let's go and turn on that layer. Let's turn on the land ownership. And I did some preliminary investigation. I found out here's that medical center, right? So a very critical infrastructure. We know how the probable utilities are. So if you're going to do any modification, one of the panelists was talking about, making sure the hospitals are correctly maintained and the service is uninterrupted. This information early on in your planning and conceptual design is very critical. A lot of the DOTs, including Nick's team, have been using the product to identify these risks early in the project concept stage. And in some situations, we are seeing the use case even evolving, where now this is being used by emergency repair crews and whatnot. So yeah, that's pretty much basically the product. And I wanted to show you a couple more things. As our product is evolving, we are identifying more and more objects. So here's a new addition to our product. Not only we are identifying road marks, but we are also identifying the flags. So a small flag on a ground, not only identified through the image, but geoposition on the map. This is one of the kind of product. No product out there will bring you GIS information plus utility object plus marking all together. And in a month or so, we will have historic road marks and historic flag going back 10, 15 years. So imagine the maturity or the richness of data that you will have at your fingertips at a fraction of cost compared to doing a full survey for that project that we are doing using AI. So I think Gen Zs will like this product a lot. That's my guess. And on top of the data, we also have a bunch of other options. For an example, downloading this to a CAD environment. So I can instantly generate a DWG or a DGN file that can be taken into design. Again, this is initial exploration. We're not saying start doing excavation based on this, but start communicating based on this information. So we are working with partners like Bentley, partners like Trimble, Esri and Autodesk, and all of them to make sure our data is well integrated in other platforms. Now let's try something on that field investigation use case. What we have developed is an API key. So I'm going to generate a new API key. And again, guys, everything is live, so let's see how it works. So G dot, and I'm going to choose a specific folder. So instead of everything, I'm just going to choose a specific folder for Roadshow. I'm going to put an expiration date for that key end of next month. So the data doesn't keep on streaming for eternity. I'm just going to publish this WFS. So what this is doing is creating a publishing stream only for a couple of projects within a folder. It's not your entire account that's getting streamed. And now we can copy that, and I'm going to hand it to Darren to show how it works on the Trimble side.
Thank you. Brilliant. All right, so what we're looking at now is a platform called Trimble Connect. Trimble Connect is our collaboration platform. It's the center point between our physical and digital worlds. Trimble's uniquely positioned to be able to speak both languages because we have tools that are in the field, GNSS equipment, we have equipment on tractors, excavators, graders, and we have the software in the office that takes that information, generates grading files for those tractors to operate on, survey construction tools, and at the center of all that is this collaboration platform called Trimble Connect. One of the really key things about Trimble Connect is it's an open architecture. So we have APIs that we can collaborate and communicate bidirectionally with your systems of record or products like what 4M is offering. So what we just saw generated was an access key for Trimble Connect to be able to go and grab this project information. We have what we call extensions here. This is called the import 4M extension. And all I'm going to do is paste that key.
And Darren, maybe before that, just one thing we want to quickly show is how that project looks in 4M. So yeah, this is the location where we map that project in 4M. You could see all the richness of the data. You could see the gas line over here. You can click on that. You can find all the information. Again, same thing. You can find the road marks. You can identify, verify a lot of this information. So what Darren will show you in a moment is taking this information, streaming that on the Trimble side. Sorry.
That's a key point.
I know.
We practiced this before, but you always forget something. So I'm going to go select our project, and we're right out here, Murrieta Street. And I'm going to give it a name, and I'm going to call it, if I can, I'm left-handed, so this is difficult.
Do you want me to hold the mic for you?
I got it. And we're going to bring that data into Trimble Connect. What this is going to allow us to do is take this data out into the field with us with the various Trimble tools, whether it's Trimble Access, which is our survey software, Trimble TerraFlex, which is our GIS data collection software, or what you're going to see in the field is Trimble SiteVision, which is an augmented reality solution. So we'll be able to visualize not only the location of these lines, but also the depths of them in the field as if we were uncovering the asphalt and uncovering the dirt and seeing those lines. So we're going to go here, and I called it, oh, go back one, GDOT. Yeah. There we go. So this is, again, in Trimble Connect, which gives all of Trimble's tools access to this very rich data set that 4M is providing. And I can zoom in here, and we can see it's the same data. It's the same attribution. I can click on any one of these lines and see all the data that's been collected in 4M system. So for this initial, we're calling this exploration of this data set. We're not like, it's good enough data. We're not digging trenches right now, but we're gonna have a crew out in the field right now showing how, as soon as I've connected this in Trimble Connect, copyright TM, our field users immediately have access to this. So we're going to pass this over to our crew outside, Justin and Dan, and they can take it away.
There we go. There we go.
Right,
I think
perfect.
we're live from the field. So yeah, hey, thanks for sending all that data through from Trimble Connect. And what we're doing is we've loaded it into Trimble SiteVision here today. And our first order of business is just to take a couple of steps with the data loaded and get it to orient kind of where we're at in the world. And as you can see, as I've walked, the data has all automatically been placed based on the data that originated in 4M is now in Connect. And now we're going to kind of take this data and put it to work with an initial field investigation. So we're going to do that now.
So we have, do you want to show where it goes into the building? So you can see this gas line here that's located, one that goes into the building as well, if we walk up by him. And then we have some fresh fiber marks, but it doesn't really tell the whole story that you see with the data. Once you get the data, you can tell as we plan a construction project here, there's just not the room to relocate any more utilities over in this area. So that's something that we can see right away, right when we get to the field, whether there's been an 811 done or not, to get us going right away.
Yeah, and some interesting things you can see about the technology here is that all of the data is overlaid on the surface, and you can see. If I change the transparency, you can kind of get an idea of the fiber lines that were identified in the database and kind of their orientation based on the paint evidence that we've got on the ground here. And we can take different visions of this, things like a pit view, so we can get kind of a look here as we walk across the street of all the utilities in the right-of-way. I'm going to try to not get run over by a car while we do this. All good here. We'll flip back and kind of get an idea of more of the utilities here.
Yeah, so as we look around, you can see the gas line mark. That's one of the concerns that needs to be relocated. As we can see on the other side, there isn't room. So it's as we think about this process, it's probably something that needs to be relocated within the road core potentially, or adjusted, worked around in the field, things like that. So we'll definitely want more data on that water main, or on the gas line, sorry. As we turn, we can see evidence of water, but we don't have any marks out in the field. That's where having this data is so valuable right off the bat, because we can see that there's water lines going through here. So we can add that into our planning just from our initial investigation here.
So in standard demo fashion, we've got a little bit of a freeze here, but there we go. We got everything's caught back up. But the SiteVision gives you all kinds of different views on it. You saw the underground view through like a pit view to give you kind of an idea of the vertical separation between utilities, the relative size of utilities from the attribution. We get an idea of larger diameter water or storm water, so we get an idea of the large utilities that might cause for concern or a heightened risk. in a particular project.
Dan,
So,
can you just pause at that view for a second? So here, you could see the communication marking on the road. Again, from an accuracy perspective, it might not be at inch level accuracy. Doesn't matter. It's an initial exploration. You can see that evidence. You can see where 4M lines are. And that gives you an idea, as both of them were saying, hey, something, if you're going to modify this sidewalk, it has a fiber line risk versus that sidewalk has a gas risk, right? Understanding that is a key. Back to you, Dan.
Yeah, no, that's a great point, Kastub, is that we're not talking about absolute accuracy in this initial part of the investigation. It's more just, let's give us greater level of context than we would have ever had, especially when it comes to sitting at your desk. You don't get this kind of this kind of exposure to the actual utilities that are out here. Comparing it to a data set, it's just it's an entirely different perspective when you have the real world and the data with you in a single view. So really powerful too. So we've got a lot of data here. We've got from one end of this project to the other, and we can continue this and make our notes along the way. So from here, we'll turn it back over to you, the office, to continue with the design.
All right, that's great. Thank you.
Okay, guys. So that's scene one. It's the field investigation. Is there any questions in the crowd here?
Okay, I've got two questions. Okay, first of all, can you import a KMZ file into this program so that you kind of can define your limits?
Absolutely, yeah. So the other project that I created, that was by the long linear project, that was by importing a KMZ file.
Okay.
So you can import KMZ, KML, GeoJSON, all of that.
All right, second question. You saw it there where they've got a telecommunication line marked. You've got the dot in the middle and then the lines either side. Is it going to interpret that as three different lines, or is it going to just understand it as being one line?
So 3 different installation will be interpreted as 3 different lines.
No. What I'm saying is when 811 goes out to mark a line, they'll put a dot roughly and then a line either side, 18 inches. So is the software going to interpret this as 3 different lines?
No, it's going to represent as one different line, and that's the buffer that it will say, okay, here's an evidence where that line will exist.
Okay, any other questions?
Can you determine if a line is abandoned?
Great question. In some situations, yes, we can. We do tell the status of the line, operational status of the line. But just being fully transparent over here, that information of something being operational or not operational needs to first land in a public domain, right? Public records. Then it gets updated. So if you're running into a situation where a line was abandoned, we won't be able to update it on the next day, but 2 to 3 months from that point of time, our data set will be updated showing it's abandoned.
Thank you.
Justin, hey, so let me piggyback off Aiden. So the marking in the field indicated a duct bank. When it's flagged in 4M, I guess that would be here, is it just going to say telecom, or would it say duct bank telecom?
As of now, it just says telecom. It doesn't go to that level of duct bank telecom, but that's something it absolutely can. So what we are, yes, 100%. So what we are working on top of, as I was showing you, like we have now markers, we have the flags, and our vision and mission is to continuously understand the markings and the physical evidences on the ground. So the duct bank will be something we'll work towards.
And I think that's am I hot? There we go. I think that's the beauty of SiteVision. If I'm outside, there's no, like, I can see AT&T's vault right there in front of me, right? And so you're able to connect real world, what you see on the ground, with what you see in 4M. You know, it's not hard for the mind to do that deductive reasoning, like, oh man, this is a vault here. whether that was a part of the initial attributes or not.
All right, so quick question. When you're looking at bringing all this data into one central visual location, are you able to bring in multiple data sets that overlay on top of each other to produce this product? Or does everything have to be merged into one solid data set?
Great question. So actually, that's the exact use case with many DOTs that we are working on. So they have their own as-builts, they have their easements and whatnot, and many, bring your own data layers that soon you will see it in product, completely productionalized, meaning you just point where the data sets are, we will pre-process that data, and again, there are different complexities of data, right? For an example, permit as-builts. Some of them are just literally close to a hand-drawn sketch. I mean, it will be a CAD drawing, but it has no GPS or GIS reference. But some of them are really good. So for the one which are very crude, we'll just show that as a point on a map, saying here is a document reference that we can provide you. For the ones where we can actually extract the lines and put it on a map, we'll do so, right? So product is exactly evolving in that direction. We will have additional layers where it's organization-specific data that you can bring in, and also the data processing that we'll do. Great question, by the way.
How the Bentley is interface with this program. Can you show this?
Yeah, so right now the Bentley interface is one directional, meaning the data from our application is going out as a DGN, 2D DGN to begin with. So Caltrans is using that 2D DGN in their workflow. But going into next quarter, we are building 3D connector with Bentley. So data from here, just like what you saw in SiteVision, we will assume depths in some situation where we don't know what depths are. And this will generate like an iTwin 3D model that you can take it into iTwin and put it with other BIM information and look at a comprehensive picture. That's the unidirectional flow we will work on. Going forward, here's how I see. I've worked at Bentley for 15 plus years, so that's a topic dear to me. We will see an integration with Bentley design tools going forward as our partnerships matures further. So someone within Bentley tool, that's again our vision, should be able to have like a 4M, just like what you saw in Trimble. You click over there, you just fetch the lines or even send your design information to 4M for utility coordination, for conflict matrix, so on and so forth.
I have a question about your assumptions.
Yes.
So what assumptions are you put into place for your different utility types?
Oh, that's a great question. So, and it's a hard one to answer because the answer is it depends. So it depends on what is the location, what type of utilities, depending on whether there was a recent DOT project where we get high quality data from, let's say, a bid that was put out, right? If a bid was put out, our engine will go and process that and update the lines. So the accuracy of line in that region will be relatively higher. That's why we're not relying on only one data source, but giving the visual evidences, giving the road marks and all of that to bring that comprehensiveness, right? So, sorry, the answer is it depends.
I've got a question. The Public Service Commission for Georgia is the enforcement arm of the DIG law, and they have a requirement called the marking standards. And it's a uniform way that everybody locates everything. Like you see the conduit run marks that you guys showed before, it was 2 lines and a dot. Well, in South Georgia, they were putting a diamond in the center. So it was a way to, and that's correctly marked, a line and a dot. But one of the other requirements is to identify the utility that you're locating. And you have to use the acronym for that service area. So AT&T, AT&T, and it's supposed to be marked on the ground. I know we're just talking about your records, and you don't have that kind of requirement here, but downtown Atlanta, there's probably 6 or 7 telecommunications easily right outside this door. Throw cable TV in there because they're part of telecom. So I don't know if you could augment for DOT's sake. That might be something that could help.
Yeah, that's a great question, and we see so much variation, not just within a state, but also across states, different ways of marking things. Some state will have strict rules of marking the utility owner on the road marks itself. So our AI engine is constantly learning, and you will see every single quarter there is like more and more data that we are understanding. Sometimes the writing is not legible. You know how those things are, but yes, we are continuously training our AI to not just identify road marks, but to your point, synthesize that road mark, identify if that's a duck bank, identify which are owners. So that's the exact direction the product will evolve. Yes.
You mentioned different levels of confidence in the line work. Is there a way to show or display the data origin of the line work that is placed?
Great question. We try to do our best to, because we are processing many documents all together. Sometimes we will be able to show a clear data set. So I'm trying to see. Yeah, most of this is private or 4M generated data set. So, but yes, wherever we can find, so for an example here, this is coming from City of Atlanta, their public records. Here are the lines that we pulled. That doesn't mean these are all the lines that we have, but we will be able to show you how it's been pulled. And one of the challenges that we face as we go into, Justin talked about this, Project Manhattan, that's our internal project, right? As we go into more and more AI application on line generation, it will be, many of the lines will be 4M generated lines, but we will back that up with the evidences on the ground that we see, like hard evidences saying, hey, here's why we think line exists because of an on-surface object, because of a road mark, because on the intersection down the road, we see a similar pattern. So our AI will give you the reasoning, so you will have better confidence in the data that we are providing. Yeah.
I was kind of going in that same space. I was going to ask, is there a way that you communicate your level of confidence in each line or the overall output file? So you kind of answered the question. I didn't know if y'all assigned a score to each line that y'all output, or if it's just here's the supporting documents and you kind of decide if it's out there or not, type of thing.
Actually, me and my manager over here, Amir, we were discussing this other week that, hey, what we are, like the demonstration I was showing you, there is a way to assign score. So that's where the product will also evolve. Again, we want to build this product together with our partnership with DOTs, with the partnership with industry. So we don't want to come out and say, hey, this is 4M score. No, that's not how it works. So we want to understand how can we better assign the scores so that we as a community have better confidence in the data that we are showing. So yeah, great point. Yeah.
And just to add to that, preparing for this live demo, we don't know, based on 4M's data, you know, they generated a lot of the data themselves, but they also source it from public records and other, you know, paper maps and everything. We don't know the coordinate systems of that original data, the datums that they were in, if they were transformed into any kind of other datums. So getting that all aligned, it's super important to know the lineage of that data that you're trying to represent in a 3D real life situation. So I would encourage you all, and that's a great point, you know, the score of that, the confidence that you can have in that, but then keeping track of your own data and where it came from and how it was produced is gonna make things like this better for everybody. That's the GIS guy in me talking.
And actually, Ed brought the same point yesterday over dinner, like, hey, we as an industry, we need to, when we look at GIS data, there is no accuracy that gets assigned to GIS data. So yesterday over the dinner, we were just talking about, hey, we as an industry need, just like BIM level of details, we need accuracy level defined as a common industry on GIS.
Okay. We found out that there are so many utilities or few, but my question is, do we have a dimension for the utility locators and the developers? Do we have a dimension of the offset from the center line of a road or wherever the development is taking place that they can get, or who is going to locate? Is it the one from your company or from the developer itself?
Yeah, so we are no boots on ground, right? We are not into locating business. We are, as I said, we are here to provide you data early on in the project without sending anyone to the field. So once you have this data, to find that exact location, it goes on to the actual conventional engineering. But you can, let's say you are more interested in a 4-inch line that we have identified, you can be very specific to the locator or the SU services that you are going for to have them go and specifically locate those lines. So yeah, we are not going to locate anything physically.
So we are going the old school way that we are detecting. Once you showed us, we are going to go the old school way that to detect where is what.
Yeah, exactly. So there is no shortcut to a SU level B or A, right? So that's not what this is going to replace. So you still need to, you want to find exact depths, you still need to do the borehole, right? This technology is not replacing, and we don't want to overpromise over there. Yeah.
All the SU firms in here, you guys heard that, right? I got
another question. Sorry. Maybe a loaded question you can't answer. Okay. Is the data eventually going to be able to name the utility type list? For example, like Georgia Power's got markings on their poles, GPC pole. Go to an AT&T manhole, you can see Bell South. Will the system eventually pick up this data, flag that as the owner? All right, next question, follow up. Is there any kind of liability concern showing the companies like that based on field conditions? And that, I assume that's being figured out.
Yeah, so to answer the first question, if the street level imagery is of a high quality, yes, that's something that's what we are training on, identifying what's written on the manhole and deciphering that, right? So that's yes. To answer your second question, if I can call in 811 ticket and I can get the markings there, that's the security we have right now. There is no restriction on the security. I can just walk, and if I can see the manhole, that's all we are saying, right? So from a security perspective, it's actually important. If someone wants to do something and try digging using this data, they might not able to achieve their intentions, right? So this is not for excavation. This is just to give you an idea. So.
Hey, does the format allow me to ask a question to Ed?
Sure.
I'm seeing his face over there, and I'll give you some time to breathe. Ed, as someone who's really familiar, very good with both Trimble and WSB as an engineering firm, right? We spoke about that in the previous question, right? That 4M does not really replace the actual field investigation, quality level BA, KN, and so forth. Ed, would you mind elaborating a little bit on how this integrates with your workflows and use cases from an engineering standpoint?
Yeah, sure. It's a great question, right? I think, somebody brought up data layers. I think you did, Kastub. Think about it as data layers, right? So our process, right, at WSB is we start with the utility map. We then bring in our locates, right, and other information from the field. That actually enhances your confidence in the mapping, right, as an example. We also do things, I heard about assumptions. A lot of times, right, and it depends on your project, so Kastub gave the right answer, but we can go into a project area and we know the utility owners, we know their let's say, standard depths they operate at, or their standard even sizes. So we even use that assumption to then model out, right, all of the 4M data in 3D. And using their APIs, I can now model out, miles of utilities in a matter of a week about. So I can very quickly go to 3D, then I can bring in my design and start looking at my design against that, right, existing data. So, I would encourage everybody in here to think about, right, those data layers, how are you gonna use them, right? We have locate partners in different states. They love using the maps just to make it efficient on how they're gonna plan their locates, as an example, right? So I've got partners, right, in multiple states that do it that way. So it's really how you use the data, and the confidence in the data grows as you start adding in, right, different types of data layers. Locates are great. If you start looking at locate data against your map, you're gonna know where you have gaps or incorrect information, right? So that's how we use it, and I would encourage you to think about, in the same way, right? How are you gonna use this data layer? What other information is gonna help you, right, look at it and be more confident in the information? And use their integrations. So that makes it a lot faster and easier. It used to take us months to model out utilities. We do it in a week.
Okay. Roz, thanks for that question, but we have 2 scenes here, and that's part of scene 2. So, Ed's kind of spilled the beans a little bit, but as you guys have seen, a field investigation was done properly to get an idea of what are some of the complexities that we're going to run into and give some early guidance on what is feasible for this project. Okay? So, scene 2 starts now. Go.
All right. So Nick, we got the initial investigation done, right? We got some fun challenges in your right-of-way that we got to look at. But we do have that early conceptual design. Do you want to take a look at what those utilities and that conceptual design look like together?
Yeah, sure. But my wife walks in during scene 2. I'm kidding. Okay. Sorry, Justin, I did that for you, man. Yeah, no, so first and foremost, of course, we got a complicated situation here. We've got, in essence, a situation where we're going to be setting curb and gutter back, which, potentially creates a conflict with drainage. As with many cities, the city of Atlanta would like to improve aesthetics, and so we've got a pole line that's under consideration for undergrounding. I saw Galen somewhere in here. Just please don't comment to that, Galen. But the thought process is to underground. And so when you've got gas mains that are conflicting with potential drainage, you've got the undergrounding of a major utility that's currently aerial, it's going to present immediate challenges. So I think first and foremost, we'd have to strategize on where we can make adjustments based on the current setback that we see. I think we'll have to take a look at whether or not undergrounding utilities is feasible in this corridor, or we need to consider reroutes. I think we'll have to take a look at what's really abandoned and what's really active in the corridor, because we really don't have the room to introduce any additional congestion. So in addition to the gas main that the guys were taking a look at across the street, it's definitely, there's a high potential that's going to be in conflict with the drainage. So.
Great, yeah, and we can't forget about our contractor community. We probably should also look out if there are any particularly large assets we got to deal with. That's what the contractor is going to want to know about. So we'll also look at any particular large assets, because those are always the most challenging for our contractors.
Great. So with this setting, let's again jump back to the product. For large assets, we could find those type of assets from over here. So there are a few water lines exceeding 20-inch diameter. You may want to go and look at that. In terms of now the next evolution of the investigation, we can start looking at land ownership. This is something we also saw in the previous project. We can click on a particular parcel. We can see who owns the parcel, what is the parcel type. Looks like this is a parking with land value and the parcel value explained over there. What I'm going to demonstrate now is one of the feature for the transportation planning. So back to that question about Bentley, this is before even the design is available. This is where you are just thinking, hey, I want to go and modify the this side of the road, so I don't have the final design, but I just know a probable area. So here, what we can do is upload. I'm going to start with uploading like a KMZ or JSON file in this situation. So here's a polygon that I've uploaded. But I can also go in and draw, for an example. I can go over here and say, this area is also area of my interest. Right? And then select a type. This is road. This is going to be expansion. I'm just going to name it expansion 1. We're going to do like 8 feet undergrounding over here. And then for the mesh 1, I'm going to also call it a road. Expansion 2 for this one. Again, 8 feet. Continue. Detect conflicts. Here are a few depths that you can provide, just a range of depths. And now what we are going through is we are creating like a monday.com type of a list for you, like a to-do list, which are the utilities within the given polygon. And you can define those polygons by different names. So here's that list of things within that particular polygons that we have drawn, the description, the location of a conflict, so on and so forth, right? So you can take this list as an initial starting point and go on to the 3D design and go on to further coordination. So with that, I'm going to hand it to Darren to talk about the 3D part.
Were you going to show your 3D model first? No, okay. All right. So again, Trimble Connect, it supports many different industry standard file formats. And even more importantly, through its APIs, we can connect directly to databases. So there's not this file sharing, because everyone knows as soon as you create a file, it's out of date, right? But if we can connect directly to a database, then we're actually looking at the same data at the same time. One of the connectors we have is with Esri, so we can stream into Esri database, Esri features in real time, update those and push those back, all in the feature services architecture. So this was a model built in Bentley, okay, by WSB. So again, full 3D model, visualization, buried utilities, above ground sidewalks, power lines, power poles, etc. What we're going to do again is push this out to the field. Well, now it's already loaded in Connect, so it's already available to our crew in the field. This is a little asterisk. We didn't do a preliminary survey out there. This is a very generous model that our friends created for us on the fly. So it's a mock. It's a mock-up of this data, of this proposed model. So keep that in mind when we're visualizing it out in the field with these guys, because we would really need really tight control to have this thing fit perfectly, and we just didn't have that completed. So out to the guys in the.
Can I add one more point? Yeah. So by the way, kudos to WSP. They turned around this model, I don't know, in a matter of a day or something like that. Yeah, amazing job. And what these guys have developed is their internal script, which runs in OpenRoad, which takes 4M data and converts that to a 3D model like this. It takes the utility objects that we have identified, assigns features in the Bentley tool, so that they don't simply show as a 3D object like a cylinder, but with actual features and connectivity and so on and so forth. So these guys have done amazing job with that. I think you are exploring with many DOTs in the early concept design how to take this 3D data, identify conflicts, and avoid conflicts even going into the design. It's like completely revolutionary way of approaching transportation projects. So once again, kudos to WSP before we hand it out to the site.
And our team out there, if they see any additional conflicts, they could note that, and office workers would be able to see that immediately, adjust their model as necessary. So this is near real-time communication between the field and the office, the physical and the digital. So with that, let's hand it off to the field crew.
So what we want to demonstrate here is the ability to take that model that WSB just created for this, just to show you guys everything that we can get with the 4M data and the conflicts that we see. So as you look up the road, you can see with those mocked-in manholes, the fiber line is going to be an issue. But we can also see in these models is any info. Just by selecting, and it'll keep that data as you move around. This helps make that decision right away in the field if our preliminary design is going to work or if there's going to be conflicts, right? We'd also see that in the office with a 3D model design. I think that's all we have to show on the
I
model
think so.
side, right?
You know, as the models get more complex, I mean, we have the ability to turn on and off certain components of the model, so we can visualize only those pieces that we want to see at a time. So we have we've got it kind of all built in and baked into one model at the moment. But the more complex models and the more properly done, if you will, we get a better view of exactly what we want to focus on when we're out in the field. But the fact that you can bring this model and not just a paper plan, but you can walk the model and communicate with project stakeholders, whether it's the contractors or you're looking to set up a laydown properly, but you've got a dangerous utility or whatever the case may be. There's lots and lots of context to be gained from using a model in SiteVision overlaid on the real world.
Yeah, and I would add, one of the things we see a value on is safety, right? So WSP does a lot of data prep for a lot of machine control contractors out there, right, that are using, right, let's say an excavation plan. So a lot of our contractors will ask us to take a similar view, but add in their excavation, right, plan and data set, so they can look at how their excavation is going to overlay with, right, existing conditions, right, against that design. So contractors are also seeing, right, value in looking at it this way.
You guys are done in the field?
Awesome. Yeah. So
all right.
Thank you very much.
And to go along with that, Ed, SiteVision is a really powerful tool for that constituent outreach. So let's say we're going to build a pedestrian overpass and we wanted to visualize what that is before it was actually constructed. You can take those models out into the field and visualize what it's going to look like. I've done it before. I've used SketchUp and built a little shed in my backyard and visualized, so my wife, could give me the approval, visualize what it's going to actually look like. She's like, no, it's going to block the window. And I'm like, no, we can model that. And so use the tools.
Yeah, it's a great point. We use it a lot for fence lines, right? A lot of landowners want to know what their new fence is going to look like, right? So you can do a lot of those types of outreach. I also like it for high risk, right, types of assets. So I've done several bridge projects. One of them was near an airport. We had a high pressure jet fuel line underneath it. So it also helps us with looking at those high, right, safety risk items. And it really does help that field team, right, visualize like, okay, I know where my problem is, right? I got to avoid hitting that thing. So it really does help in lots of different ways.
And if we think about the future, right, let's say when a project is being constructed, let's say we capture the LiDAR scan. And 3 years from now, you are out there and you can just simply bring that LiDAR scan along with the utility data, along with the 3D model. Then you have such a big, it's a completely transformational way of working, right? So I see that's where the technology is going. Justin? Oh, we got a question.
I was just curious, how long did it take you to gather all this data for this one demo? I mean, it's not like you just did it in an hour. You had to get all the data to put it all together. So
it actually is pretty fast, right? So the process steps, right? The easiest one is 4M. You draw your polygon, your KMZ, your KML boundary on your project, right? So that immediately gives us that utility information, right? And then what we did, right, it took a few days, but we then bring all that data into the Bentley environment, right? So we can set it up there. We have the automated scripting. So part of what makes this a fast process is we're using integrations and automation. We're not manually, right, taking the 4M data in 2D and then manually modeling that in 3D. So that was done really quickly, right? Now, I will say we had to tweak some of the data because we wanted it to look more realistic, right? That probably took a couple extra days, but everything you're seeing was done in, probably less than 4 days, right, work. So it is rapidly speeding up our process, right? I know DOTs like to hear that, right? But contractors do too, because we're getting better data sets earlier. And that's really what our contractor community wants to see is, hey, give me better data. I want to manage my own risk, right? And the faster I have that data in my hands, the better off I am, right? Before I start construction.
Okay. So a round of applause for everyone up here. Great job. I can tell you acting is not in their future. But we're going to open up the next 10 minutes for conversations or questions from the audience. Feel free to ask anyone up here, and then we'll transition to the next. So we have 5-10 minutes. Anyone else have any questions about what was happened in scene 1 or scene 2 today? Okay, we got.
Will the video be available that was scene 1 and scene 2 that we could access later and show colleagues?
Absolutely.
Yeah. All right, before we go on to the next question, let's welcome the team on the field. Real humans doing real job. Yeah. I know it's cold out there, so yeah, thank you for sticking out that long. Yeah.
I guess this is more of a statement than a question. I'm sure my fellow Sioux people and some of the engineers probably have some concerns with the 4M, but if we follow the 3822, 4M is just quality level D. I've worked with 4M, not directly, but as a subcontractor from another company, and it was invaluable to have this information. It's just records research on steroids. It's nice. I did Sioux in Colorado, and with the Colorado Sioux law, records research is paramount, even for a small project. So this just gets you as much of those records as you can in an hour, instead of having to call, all your telecom companies and your water company about, hey, I really need those records. And it's 2 weeks later, and hey, I really need those records, and they still don't provide them. This gets you as much as you can. I know when I first saw 4M, I was, as a Sioux guy, a little worried, but, ASC 3822 still requires, survey and being attached to a project datum. None of this 4M stuff is attached yet, but I guess, it was just more of a statement than a question. Thank you.
And just to add to that, right, like there are projects, for an example, there was a project in Houston area, actually WSP did that project where the problematic sewer line was identified very early on. So they might not have gone for a detailed inline inspection and sewer investigation, and our technology just enabled that. So you will see, yes, to your point, it starts with record D, but this will help you even gain more business where it's really critical in that early phase of the project. Yeah.
So I'm guessing this is a subscription-based service, or how do you get this information?
Yeah, it's a SaaS subscription. I can't speak. Yearly subscription. That's what we have. We do have our account executives here. They can explain you in detail how our model works. But depending on how much volume you want to consume per year, we have a different subscription tiers.
How do you see this progressing into design plans and sheets and stuff, or we actually go from here to actually where you take it to the field and build it. I mean, you have, you know, the plan sets and everything, and MicroStation. And then conversely, going back and forth, when the designer changes something, do you see that going back and actually updating this model as well?
Great question. So that brings us to a topic where product is evolving on data updatability, right? Because many of these transportation projects, they're not 6 months project, they are 6 years project, right? So you start at a concept, then same location, something will happen in the design side or the field locate side, 4M data needs to be updated. Not only that, during that period, there might be other utilities that are getting installed. So there is a data updatability where you draw a project at concept, then again maybe draw it 6 months later or 1 year later, 10%, 30% design. And the key to make it work is have a feedback loop. Feedback loop with our technology partners like Trimble, Bentley. So any changes in the design are fed back into 4M and vice versa. So that round tripping of data is how we will make it work.
Yeah, and I can say for GDOT, you know, we've kind of pushed the envelope beyond our design efforts to kind of expand that into the field with our inspectors and, you know, for unidentified utilities or any type of risk that comes up that wasn't foreseen in design. You know, like it was mentioned earlier, we have used it in emergency response when we've had, you know, down facilities and main breaks and things of that nature that we didn't have access to design plans or SUE deliverables. We were able to use it. For our coordinators who are reviewing permits that are coming into GPass, and you know, there's question about facilities that may be there and how it aligns with the existing utilities in their plan sets. So my encouragement would be view this through the lens of a full life cycle. Like the facilities in the right of way for GDOT, they're not going anywhere. They're here in perpetuity. Right? Unless you move it, it'll be there. And so we plan this, we see the use of this product as our way to manage this asset through its full life cycle from cradle to grave and vice versa.
Yeah, and I think that's a great point, Nick, right? One of the things we spend a lot of time on with 4M, right, just as a firm ourselves, is how do we actually get the most value out of the data? And you're exactly right. Like, I'm not gonna just use it for, right, early conceptual plan. I'll use it for planning and program, right? Looking at my entire program, my network. I can look at it for maintenance and asset management. You know, there's a lot of GIS people, I assume, in here, right? There's a lot of interest in how do I bring 4M data into my GIS and enhance my, right, mapping data. So there's a lot, you should be thinking about those things to get the most value out of it.
Okay, is there any other questions from the crowd here? Yeah.
I have an input comment that is, this 4M is very, very helpful, very beneficial for utilities and district SUE crews, because I had projects during construction that utilities were stating that they don't have facilities or there is no conflict on the project. I have used on several of those projects, and I have used this and identified that it was there. So it is very, very important, powerful, and minimize and eliminates risks and utility delay costs. I have to say that. I'm the usual user.
Thank you. Yeah, that is amazing. All right, if no more questions, one more time, big hands to our Trimble team who was out there in the cold. And again, thanks to WSP for bringing it together. It's truly, and thanks to Nick, it's truly building better together. So thanks for this opportunity.
Okay.